15 to 1.5 present here. For the next 30 minutes, we'll be discussing on Python dictionary basics with few hands-on, and I'll not be looking into the chat window. So if you have any doubts, then and there you stop me, you unmute your mic and raise your queries and clarify, right? So let us straight away move to the presentation. Whether my screen is visible now?
Yes, ma'am.
Okay. So actually, dictionary is very wonderful data structure. The Python language itself is built around different dictionary. We do not know. All those are said to be the Python internals, right? And before getting into dictionary, I want to have a very brief discussion on Python. And then so normally it's like feeling peaceful or relaxed, or feeling peaceful and relaxed. And this statement, feeling peaceful and relaxed, is not for the language developer, it's for the application developer, right? And actually this Python is influenced by many guiding principles. There are 19 guiding principles which one of the team member has listed out in the as Son of Python. So, and that guiding principles can be listed by executing the single statement import this. And I have pasted a picture there. Actually related to Son of Python, I got a wonderful picture from internet. Since it is updated one, I am not supposed to place it in my presentation. And when you look this picture, you can find only a few icebergs above the water level, and below that there is a huge amount of icebergs. So this is what Python. Above the water level, what you see is the Python interface, and below the water surface, what you see is the Python internals. And of course, all the internals are developed using C, C++, even Python 2. And as we know, there are different types of Python implementations like that, Python. The most complex one is C Python, and we are demonstrating through the C Python. I'll show that. And so this is what my agenda. I'll tell you what is dictionary, what is the need for dictionary, what are the properties, that's all. And before that, let me move to the command prompt. Is the command prompt visible?
No, ma'am.
Yes, ma'am. Is it no? No.
No.
Yes. Yes, sir. No.
No. Now it's visible.
Yeah, I think now it is visible.
Now
right?
it is visible, yes.
Yes. So this is okay, fine. This is the command prompt. So yeah, I got the command prompt now. Initially, I want to check what type of Python implementation I'm using. So let me type two statements for that. Import platform, and my module platform dot, there's a method Python underscore implementation. Yes, this returns me that what implementation I am using now is C Python, right? Okay. And now this command prompt is, this is a chevron symbol, and I don't want to have this command prompt, this symbol as my command prompt. I want to change it. So let me import another module, say sys, and I'm setting one of its variable sys.ps1. So the space is a predefined variable, and I'm changing it to by Sabha this symbol. So this is what my command prompt. So whatever statements I execute, everything will be executed fine here, right? Yes. Let me type import this. You are getting 19 statements here, and all these 19 statements are the guiding principles that influence the design of Python programming language. Fine. And we too saw a picture there, right? I'll demonstrate that picture with only one statement. And people whoever start to learn Python will be very much wonder about the statements a comma b equal to b comma a. Is it not? Yeah, I haven't declared anything, that's why I made error. A equal to 10 and b equal to 5. And now write yes.
Can your account understand please one second? Can you tell me? The first thing imports SYS I can't. Starting sounding like the command prompt ஆரம்பிச்சோம்.
Yes. These are very fundamental things. These are very fundamental things just to check what kind of Python implementation we are currently using, and just to change the command prompt. That's it. It's not going to create any impact on your programming or anything else. You can show your students all this. Only for that purpose and executed that. Okay? Yes. So I hope everybody would have felt happy the moment they have seen the statement a comma b equal to b comma a. Is it not? Of course, I was very happy to see the statement a comma b equal to b comma a when I learned Python for the first time. Okay, and actually Python is the most popular language nowadays. Its popularity is because of the smartness. How smart the developer can do code. Instead of writing 100 lines or 200 lines, there are options in Python where you can replace all those 100 or 200 lines with say some 20 lines or even some 10 line of codes. That is the beauty of Python. Okay, and let us see how this a comma b equal to b comma a is made simpler to the application developer and how hard it is to the language developer, right? Okay, fine. Let me put this in a function. Def swap of a comma b, and I'm writing statement a comma b equals b comma a. That's it. This is my function where I have placed only one statement a comma b equal to b comma a. And let us see how the system internal works for this smart statement a comma b equal to b comma a. Don't bother about all this more statements and other things. You just understand. That's more than enough. Yeah. You can find assembly language programming statements here. Don't panic looking at this. I'll explain in a very simple way how internally this a comma b equal to b comma a statements works. So actually the right hand side is evaluated first, and what is there in the right hand side is b comma a. So b is pushed into the stack, and then a is pushed into the stack, and then next to that you can find here a ROT2 statement, and this ROT2 statement is just to rotate the top two elements of the stack, because you cannot just assign this a to a and this b to b. Have to rotate this. So that's why I have used ROT2 function, which rotates the top two elements of the stack. So when this top two elements of the stack is rotated, you'll get A at the bottom of the stack and B at the top of the stack. Now the left hand side is evaluated, that this B is assigned to this A, and then the next compartment A is assigned to B. Actually, whatever I explained now is implemented the internal parts by the developers, and this smart statement a comma b equal to b comma a is used by the developers. That is why we say Python is a smart way of writing programs. If you want to swap 2 numbers, then ROT2 will work fine. If you want to swap 3 numbers, then one ROT3. But if more than 3 numbers need to be swapped, they don't follow this approach. Instead, they go for a tuple assignment. They push everything into the stack and they package it as a tuple in a reverse order and then they store it. That is how multiple assignments are done. So this is the beauty of Python. I demonstrated this just to make you to understand how beautiful language is, right? Now we'll move on to dictionary. Yes. What is a dictionary? So I say it's a collection which is ordered, changeable and indexed. Do you have any contradiction in this definition? Please let me know. I am not looking into the chat. No response? Okay, I'll tell you. Hope many of you would have searched in the internet or you might have referred some textbooks where you can find in some places, not in some places, in many places you would have noticed Python is a collection which is unordered, and of course in old textbooks too you can find the word unordered, but currently it is not true. Python is a collection which is ordered sequence, right? And from Python version 3.6 onwards, your dictionary is an ordered collection, but the Python Software Foundation officially announced it as an ordered collection only from Python version 3.7 onwards. They have made a small changes in their hash table, that's it. Let us not go much deep into this hash table, I'll just brief it, okay? And of course the second point is changeable, where you can change the item values in a dictionary and index. You are indexing it through keys, right? Now let us look these two pictures. The left side is a hash table. So this hash table structure is followed until Python version 3.5, where you have a key and you have a value. Actually what happens is, whenever we enter a key or whenever we create a key, the hash value of the key is calculated and this hash value is mapped with memory, and in the respective memory the value is stored, right? Say for example, if you have a key named key0, it has got a hash value and that hash function will return some address, and in that address the key is placed as well as the value is placed, and again this table is another array kind of thing, right? So this is how the key value pairs are placed into the hash table, and when we try to print the dictionary until version 3.5, it will be printed from key 2 value 2, key 1 value 1, key 0 and value 0. That is why we get an unordered collection in dictionary and version 3.5. But now they have made a small change in the hash table. Look here. So the same key 2, key 1, key 0, but they are mapping or they are referring it to another table in the way. Got it? They are establishing some references to make it ordered. That's it. That's why we are getting from Python 6 onwards dictionary as a collection of ordered sequence. Okay. And when we speak about dictionary in terms of Python, we'll be writing it within curly braces, and your curly braces will have number of items, and each item consists of a key value pair, and the key value pair are separated with colon. This is the syntax for a Python dictionary. But from programming point of view, actually the Python is a container. So I say it's a container because the Python dictionary alone, the empty dictionary alone has its own unique address. Then in this container we are placing number of items. So obviously each item will have its own address. I'll demonstrate that, okay? And need for a dictionary, you have list, you have tuples, you have strings, and of course your tuple data structure and your list data structure can have mixed data types. Then what is the need for this dictionary? That's the reason behind it. Since this hash function is used, it helps for a faster lookup. So it makes you so easy to read any values or to make any updations or changes in the value because of this faster lookup which is done through this hash function. That's why they say the best time complexity is order of 1 in Python for any search, and of course here too we have bus complexity which is order of n, that is obvious. Okay, and next one is creating a dictionary. There are 6 different ways to create dictionary. I am not going to cover all this 6 ways. I'll explain only one. From that we can move slowly, right? Okay, then we'll move on to hands-on hereafter. Let us not go to this presentation. Okay, can you see the command prompt?
No, ma'am. No command prompt. Only PPT.
Only PPT. Okay, let us wait for a second. Let us wait now. Oh,
Yeah. Yes, ma'am.
yes.
I displayed.
Yes, okay, fine. So, let me demonstrate how to create an empty dictionary first. Okay. So, myDict equal to empty. This is one way to create an empty dictionary. Okay. So, myDict equal to, how to check this is a dictionary? Of course, we have a type function, type of myDict. So, this says that whatever you have created or this object is of type dict. And we say in Python everything is an object. Don't forget that. Okay. So, this myDict object is of type dict. Fine. I told you that this is a container. So, if it is a container, definitely it should have some address. We can check that too. ID of myDict. So, this gives the integer address of the container myDict. Is it clear? Any doubts you have? No doubts?
ID means, ma'am?
Sorry, ma'am?
ID means it refers to the.
ID is a function. ID is a function, ma'am. This function will return the integer address of any object in Python. Clear?
Is it an object ID or?
Is it clear? ID is a function, right? ID is a function, and this function takes Python objects as its argument. And myDict is an object. myDict is a Python object, no doubt about that. I am passing this object and I am finding out its address. That's it. Clear?
Okay.
Shall I proceed? Okay, fine. So, ID of myDict gives the container address, which is some long integer number. Very good, right? Now, slowly we'll try to add some items into this dictionary. So, there are different ways to add keys into dictionary. Let me create a key name equal to Deba. So now my Python dictionary consists of how many items? Only 1 items. And as I told you, each item consists of a key and a value. And here the key is name and the value is Seba. Let us print and check. Yes. My Python dictionary object consists of 1 item whose key is name, whose value is Seba. Right? And let us have some discussion on the key now. Okay. Key is very, very important. You can have different types as key. Am I right? You can have different data types as key. What type I have set as key here? No response. What type I have set as key here?
String.
String. Very good. This is a string. Yes, string, right? Can I have integer as key? Can I have an integer as key? Yes.
Yes.
Can I have a float number as key? Yes. Can I have a boolean as key? Yes. Can I have a tuple as key? Yes. Can I have a list as key?
No.
No, ma'am.
No.
Can I have a list as key? No.
No.
Why? What is the reason?
This will search a set of elements. No.